Hello learners, so in this session we will study about clustering technique that is being performed in R. So in the previous session we have already studied about the classification technique. So we have seen that there are various decision tree algorithms, more specifically decision tree that is conditional decision tree, and then there is another one that is more advanced version of decision tree, that is random forest. So we have seen that uh, we can use various algorithm to classify for a particular problem. Similarly, all the session in in previous session we have seen supervised learning technique. So in this particular session we will see about clustering, which is a unsupervised method that is being employed in machine learning and deep learning algorithms. So clustering is the name, as the name suggests, is nothing. It is a form of clusters that suppose there are three clusters. Cluster means that in a cluster the elements within a cluster will be very close to each other, and the elements that are inter-cluster. So we will take, there are two things to consider in clustering. So there are number of clusters that can be formed. So inside the clusters there will be elements, and there inside the clusters there will be element. That element will be close to each other. So inside a cluster the elements are very close to each other. That is why they form one group. So like group of teachers, so they have more features that are identical, so that they are arranged in one category. Similarly, there can be other cluster that perform different function, uh, like in a university environment you can think of it like that. There are workers, there are professors. Okay, so professors will constitute one group. Workers, that is the staff that resides in the university, that will perform another cluster, because they have different task than the professors, because professor primarily task is to teach the students, and workers or clerks have a primarily task is to maintain the working of the university. So these are two different clusters, and they are within the cluster, they are very close to each other, but inter cluster they are different than each other. So that is the basic concept of clustering that we have seen. So clustering in R programming is, again remember that it's an unsupervised learning technique. So previously we have seen supervised learning technique, where we can divide the data into training and testing, and then we train the model accordingly, and then we give the testing data to the trained model to check if the model is good or not, if the fitness of the model is good or not, by predicting, and that prediction will be compared against the ground truth value. So if they are very close to each other, the confusion matrix will say that it has around 100% accuracy, 95% accuracy, overall accuracy in predicting the right class. But in clustering it is very different than the classification part, because in this there is no training that will be happened. So you are directly given the data, and based on technique, based on specific algorithms, you have to arrange the data in clusters. Now again, the cluster should be formed in such a way that the elements within the clusters are very close to each other, and the elements that are intercluster, that are a part of different cluster, are very different from each other. Clustering is a unsupervised technique that divides a dataset into multiple groups, which is called a cluster, based on the similarities. After segmenting, means dividing the data clusters are generated. All objects in the cluster have common properties. Clustering is basically mainly used for data mining and analysis, that in order to find the more relevant samples that are close to each other. So the application here is, the application of clustering is in marketing, like in marketing, you can think of it like clustering is helpful in marketing. This can help you identify market patterns. Like if you think that which particular same product, if you like mobiles, you will like a set of mobiles of different companies. So it is like that. You can, if you are following a certain mobile, so the shopping app can simply show you different company mobiles with different specifications. So they are a part of the cluster, but they are very close to each other. So the clustering can be, again, within the clustering, you can, in clustering, you can also divide it based on the categories, like the pricing category, the $10,000 phone, 10,000 rupees phone, 20,000 rupees phone, some, and you can divide the clustering based on that as well. Another is internet. You can browse many website, but again, the website which is more similar to your interest will also can also be shown, uh, uh, can also be divided into categories, the categories that you like and the categories that you don't like. So browsing history can be aggregated and clusters, and a user profile based on that browsing history can also be generated, that a particular user want to use this particular set of websites. Another is games, like you can also use clustering algorithm to cluster similar type of games, like if you like fighting games, and similarly another type of fighting games can also be of your interest with some with different characters and different actions that you can find in other games. So it is very what you say, very close. If you, it is very accurate. If you like a certain game, you will definitely like similar type of game that is very similar to the game you like. Suppose you like A game and B game is very close, the plot is same, everything is same, the characters are different and the action sequences and something inside the game is different, but it is very close to game A. So you will find it more familiar to like game B, and you can browse based on this. So that is why clustering is very important, and it has separate applications. Similarly, in the field of medicine, you can also find new inventors of medicine. So similar type of medicine, occasionally new species are discovered by researchers and scientists. Those category can easily be found by using a clustering algorithm based on their similarity. Okay. So there are two types of clustering that can be considered. First is hard clustering, another one is soft clustering. So what is the difference between these two? So in hard clustering, data points are assigned to only one cluster, whether they belong entirely to the cluster. The algorithm used for hard clustering is k-means. So what it means is that so it is either belong to a cluster 1, or it will belong to cluster 2, or it will belong to cluster 3. Suppose if there are 3 cluster, either it will belong to cluster 1, or it will belong to cluster 2, or it will belong to cluster 3. So there is no other cluster that is there. So another one is soft clustering. So soft clustering is also based on the degree. So like the boundaries are not conventional. Like if it does not mean that it is belonging to a certain set. It belongs to a certain cluster, like K, it belongs to a certain cluster K1. So this is not in case of soft clustering. So here we assign the probabilities of data points in cluster rather than placing each point in a cluster. So it will be the degree. So this particular point belongs to cluster 1 with 60% probability. So this particular point belongs to cluster 2 with 20% probability. Something like that, you can think of it like that. The example here is fuzzy C-means clustering lies in this particular part of soft clustering. So another one is you can apply fuzzy C-means, or soft K-means is also a technique that is implemented in R for soft clustering. So in this one, we will see the hard clustering technique, that is K-means clustering. So K-means clustering is a very popular problem in machine learning. So it is used for basically it is used in data science for data mining, and you can just simply perform different set of clusters based on the values that are coming inside. Okay, so the algorithm itself is very simple. First you have to pick that how many clusters can be performed. Okay, so if there are like based on the data set, suppose I am thinking that there are two clusters, I have to divide this data into two cluster. Now after dividing into two clusters, you have to figure out any of the points that is coming at a random. So suppose there is third point. Now you have taken two particular clusters. Now the third point will either belong to cluster 1 or cluster 2. So if there are two cluster, either it will belong to cluster 1 or cluster 2, which depends upon some distance measure. Okay, so you will employ some kind of a distance measure and you will calculate the distance of the point in question towards the point cluster K1, and you will find the distance measure from the point cluster K2. Okay, so based on the distance, so if you have to select the minimum distance out of these two. So there will be two clusters. When you calculate the distance between these two, the minimum will be the closest point. So you will place that particular sample inside that cluster. Suppose there are two values that comes. For cluster K1 the values is 0.6, for cluster K2 the value is 0.4. So you will take the value of 0.4 and you place it in cluster 2. So again this is not done here. Again you have to calculate the centroid. After putting the value in between, you again have to calculate the centroid. I'll tell you about what is a centroid calculation, what are the formulas, and after that again you will take another point and you perform the process, so on and so forth. Okay, so keep that in mind that every time when you are assigning a value to a cluster, you have to again recalculate the centroid. So I'll show you what do I mean by this. So suppose I'm taking an example where there is a height and there is a weight. So there are 12 values of 12 persons which have height, and based on the height there is a weight. Okay, so suppose 185 centimeter have a person have 185 centimeter and have 72 kg weight. Similarly, a person has 170 centimeter height and 56 kg weight, and so on and so forth. Now first step is to calculate the centroid, that is also referred to as the cluster. So this is one this is already given that you try to form two clusters. So this is already given to you that you perform two clusters. Now there I have selected two particular centroid. You can select it. So first one centroid I have selected is 185,72. It means 185 is the height and 72 is the weight. Another centroid is 170 is the height and 56 is the weight. So the next step is to find out the Euclidean distance between other points. So the remaining, these are two centroids that I have taken, and the remaining 10 values. So these are two, the remaining 10 values will be checked based on the distances. Okay, so the third point we have taken is the third person has 168 centimeter height and 60 kg weight. So now what happens here is that you have to find the Euclidean distance from point 3 to centroid 1 and from point 3 to centroid 2. So the formula here for calculating the Euclidean distance is observed observed x value minus the centroid x value plus, that is the, now it is the square, plus observed y value minus the centroid y value square, and is in the under root. So this is simple formula of Euclidean distance, so that there will be no negative value. So we are squaring it and it is kept under the square root. So now check. Point 3 value is 168,60. So what you have to do is take the value, you have to see that point 3 is either closer to the centroid 1 or point 3 is closer to the centroid 2. Centroid 1 is 185,72. Now put the values of centroid in x centroid. So what is the x value of observed? Observed value is 168 minus what is the x centroid value, that is 185. You square it plus what is the y observed value, that is 60, and what is the y centroid value, that is 72. So you subtract it and then you add it, it will become 20.80, and same thing will be performed for the second centroid. Everything is similar, only the x and y centroid is changed to 170 and 56. Now check here, this value comes to 4.48. So if you check here, what is happening here is that there are two values. Point 3 has a distance of 20.80 from centroid 1 and has a distance of 4.48 from centroid 2. So which is the closest? So the minimum one is the closest. So what it means is that point 3 belongs to a cluster of centroid 2. So you will place the point close to the cluster of centroid 2. So it is as simple as that. Now this is the main step here. Now after you placing the point to the centroid, you again have to calculate the new centroid, because you have placed the point at this particular centroid. So the value should also be changed because of that. Why? Because you are placing more points here, so you have to take the average of those points. So what is the, how to calculate the new centroid? So you simply just taking the x-axis and y-axis, adding them and divide it by 2. We're just taking the average value. So that is how new centroid calculation is performed. Now for centroid 2, the calculation for centroid 2, the value becomes 169,58, and for centroid 1 it is similar, because there is no particular point that is being attached or put in the cluster centroid K1, so the value remains the same, not changed. So after updating two clusters, centroid 1 is the same, centroid 2 changes to 169,58. Okay, so this is the main step that you have to perform, that after putting a point you have to again update the centroid. So you can think of it, what are the results? So this is that you have to perform this process, so on and so forth, and then when you stop you will find that the result is that in cluster there are 1 4 5 6 7 8 9 12 10 and 12 people belongs to cluster 1, and in cluster 2 that is 2 3 and 11. 2 3 and 11 the clusters that are very close to each other. Okay, so you can check it from here as well, because the height is very close to, of 2 3 is very close to each other, and the height of 11 is also close to 170 or 168. So you can put those into the same cluster. So the weight value is also not much changed here. 256 to 60 is the weight value of 2 3, and if you check the weight value of 11, that is 67. So you can think of it like that, that they are placed in the same cluster. because they are very similar to each other. Okay. So in the cluster one there are more values, and in the cluster one there are two less values. So you can see the formation, or you can see the example here, that there are you can also take any other data set and you can perform the clustering like this. On the graph it will look like this. In R you can simply do the clustering is very simple to perform. Okay. So how to do it? Simply start with the syntax, that is k-means, followed by 3 arguments. The first argument is x, that represent a numeric matrix, or also referred to as a data frame object. Another one is centers, that represents the k value or distinct cluster centers. So this is another cluster value that it can represent. Another one is your start represents value, n start value. So n start represent the number of random sets that have to be chosen. So this is how it is. So I'll show you with an example what it means is. So firstly, we will take the same data that we have taken in the previous session, that is of iris data. It will have three different types of flowers. We have already seen that depends upon the features: sepal length, sepal width, petal length, and petal width. Okay, so their three categories are virginica, another one was vernicolor, and another one was setosa. So the input is again based on this. So the data set contains three classes, and every class will contain 50 instances. So this particular thing is referred to as balanced classes. So every particular instance contains similar type of features. What it means is that three classes have equal instances. So what it means, there are 50 samples of class 1, 50 samples of class 2, 50 samples of class 3. So this is referred to as a balanced classification problem. So if there is something like that, there are 50 samples of class 1, 25 samples of class 2, 25 samples of class 3. Now this particular problem becomes unbalanced classification problem. Okay, so in this one we are using a balanced classification problem. Moreover, we will also be, this is not a supervised learning, this is unsupervised learning first, and in the next one that you may see that we will see the three clusters, and three clusters you can see it on the graph. It is very simple to implement. Okay, so firstly you have to install the package that is referred to as cluster with a capital R. Either you can write install.packages and another package is cluster. So two packages that you have to install. After that you have to import those packages, and we are using the data frame as iris -1. So after that this particular part will delete, this will not take the ground truth value, that iris underscore df equal to iris square bracket comma -1. This particular this particular line of code will only take the features, they will not take the class, because we already know that this is the unsupervised problem. So there is no need to input the result here. So you will only give the features to the clustering algorithm. After that it will cluster based on the distances between the features. Okay, so this is what I mean. So now the implementation itself is very easy. First you set the seed so that the value should be same. Then k-means dot res equal to k-mean iris. Now this iris underscore df will only contain the features of different flowers. It will not contain the class. Now you are taking centers as 3. Center means that there are 3 proper clusters that have to be formed. It means a flower can either belong to one of the 3 classes. That is also there because we already know that there are 3 species of flowers. Now when you start it, you just press enter, and then you can print the value of k-means and res. So it will show you that how much when you when you want to when you enter k-means comma res and you press enter, it will show you how many in which particular clusters, uh, what are the sizes of each cluster that have been predicted. Okay, so you can see that that how many flowers are being classified into a class. So that you can see by simply writing k-means comma res and pressing enter. So it will tell you that there are 3 clusters, each with the size of this. Okay, so now you can also check the what are the cluster names, and you can also check which cluster contain which values. So if you write it, it will reply like 111, 222, 333. So what it will do is that it is telling you that this from this column number, from this row number to this row number, the value is 1. From this row number to this row number, the value is 2. From this to this, the value is 3. Because there are only 3 clusters, so it will be based accordingly. So you can check the output after that, and you can also draw the confusion matrix, because the 3 clusters are made which are of 50, 62, 38 size respectively. But actually you already know that these 3 classes are three of the classes have 50, 50 and 50 samples. So if you check here, the clustering is not much accurate as compared to the supervised algorithms like random forest, but still because it is not wasting time for training the model, that is why it brings the accuracy that is much more than without training the algorithm. So that we will prefer clustering in some cases, we will prefer classification in some cases, but the clustering part is based more on the similarity of the features. Okay, so if you check here, the accuracy here is only 88.4%, and when the confusion matrix is drawn, so Setosa model is predicted 100% right, but versicolor species is predicted 48 out of 50 right, but 2 instances are not correct. In case of Virginica, 36 are correct and 14 values have been incorrectly predicted to class versicolor. So that is how you read a confusion matrix. That is why the accuracy decreased to 80 or 88.4%. But check here, we have not wasted time for training. So you directly started building the model, because that is the use of unsupervised learning models. So you can also you can also visualize the model. Simply write these statements that we write plot iris dip and sepal length, sepal width. When you plot it, you will see that there are 3 different points on the graph with different colors. Okay, so you can see that there are some points like red points are inside the green points. So these are the misclassification part. So it means it had calculated the distances, but the features are very close to each other. That is why it placed them together. Okay. So similarly, if you want to plot the cluster centers, you can also simply plot it by simply using this statement. You can simply write points k-means dot res dollar centers, and then you can write for what sepal length or sepal width you want to do it. So it will perform that whichever is the center point of the three classes. In the similar way, the plot will show that the center of the cluster which are marked as cross sign with the same color of cluster. So you can check. Now you can also plot cluster center by using another command. sepal length, sepal width, that is it. Now you can also visualize the cluster. So the one thing is that you want to, what you do, you want to put a boundary where a particular cluster belong to a particular class. So for that you can also use this particular command that is referred to as clusplot. So what you have to do, you just have to pass the data set, that is the data frame, and then based on the data frame you will pass what particular columns you are taking, that is sepal length and sepal width, and then you can easily pass the k-means res comma cluster, res dollar cluster variable. So you pass it. After that you can set various parameters and it will draw the line across the boundaries of the cluster. So you can see here cluster 2 and cluster 3 are very close to each other and some of the area are overlapping. So that is why there is accuracy, there is not much accuracy because the features are very close to each other. So that is why the case here that that there is misclassification occurs. Okay. So we have seen classification, we have seen now clustering. So the main differences between these two things is that first thing that you always have to see, the clustering is always unsupervised. So what it means is that it will not waste much amount of data on training. It will directly start aggregating and start putting the points into the cluster and do it very quickly. But in classification you always have to train the model first, only then you will move on to the testing part. Okay, so these are the two differences between classification and clustering. In the next session we will see about the association rule mining and how the different algorithms can be used for rule mining and rule generation. We'll see in the next session. So thank you.